Hello, hello. All right. So, lower sec mathematics. Okay, 6 o'clock already. Let's begin lesson. Let's go. Let's go. Okay, let me see. Okay, just now. Oh, hi, Jethro. Hi, Kevin. Hello, Shina. Hello, Sydney. Hi to all. Okay, our Sec 1, Sec 2 lessons should begin very soon. Okay, so what is happening is wait, can I just message first? All right, got one student asking me a question, so I need to reply first. Just give me a second. All right, because I'm a man and men cannot multitask. All right, yeah. Okay, so I'm back to you. Okay, so as you know that we are doing our Sec 1 lesson, your school, right, for Sec 1, maybe you haven't do this topic yet. It's about something called the volume of the prism or the total surface area, all right? So if you haven't done, it's okay. So don't worry about it. If you're Sec 2, definitely you have done something called prism already and you know what is it. All right. And for Sec 1, right, I'm going to teach you something extra in Sec 2, all right, where we are talking about something called the volume of the cone, volume of the sphere, and also volume of a pyramid. All right. Just remember by formula for now. Okay. So you can understand how the formula works. That will be even better. B-E-T-T-E-R. All right. So let's go on to our lesson today. So the first thing is what you need. It's the same thing, right? So let's skip. Okay, some of the key formulas that you need to know. All right, some of the key formulas you need to know are for the Sec 1. This is for the Sec 1. So for the Sec 1, Sec 2, just take it as a revision, can? Okay, Sec 1. The one word, right, which comes to your mind is this thing called prism. All right, this is part of the Sec 1 syllabus. What is prism? Prism like prison like that, not prison, prism. All right, so what is a prism? A prism to me, right, is a three-dimensional shape. I call it 3D lah. A 3D object. All right, this 3D object has a constant what? That has a constant area of cross section. All right, area of cross section. What is a cross section? Don't worry, later I explain to you. All right, so can you please, inside your exercise book or inside the worksheet, right, find a place to write this. All right, what's the meaning of a prism? Prism is a 3D object. 3D, D means three-dimensional object that has a constant area of cross section. Can? Let me show you what is a prism. Example of a prism. This is a very, very famous example. So nice one. All right, this is a famous example. What is this called? All right, you learned this in primary 5 already. What is this called? This is called a cylinder. All right, a cylinder. Do you know that a cylinder is a prism? All right. Prism is just a general name, all right? It's a general name for objects that is three-dimensional and has a constant area of cross-section. A cylinder is a prism, but the special name for this three-dimensional object is called a cylinder. Can? All right. So, okay. So, why is it called why is it called a prism? Again, right, for a cylinder, if you take a knife, right, and you slice like that, all right, you take a knife and you slice from left to right, left to right, left to right there, all right, what do you get? You keep getting what? You keep getting something called circles. Can you see now? All right, if you slice like that, like you play game like that, slice, you keep getting what? Circles. And guess what? These circles are what? These circles are the same size one. That's why it's called constant. All right. So the area, right, of the top and the bottom, right, can you see now, of the cylinder, is the same size throughout. All right. So if you keep slicing like that, right, you keep getting the same circle, the same area. This is something called prism law. That means this shape. What is this shape? This shape is a what? Okay, I haven't drawn. How you know? I also don't know. All right, this shape is called a cube. Can you see not? This shape down here is called a cube. Oh, wait. Nice, right? My drawing, I know. All right, you can train also. All right, this shape is called a cube. A cube, right? If you slice like that, what happen? Okay, you keep slicing, you keep getting a what? You keep getting a square, 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 squares. Can you see that? All right, so this square, right, is consistent throughout until you cut to the last piece. It's still the same size, the square. Can you see that? That's why the cube is also called a prism. Very good. How about this? How about this? Check this out. Check this out. What is this? All right, this is called a okay. Maybe I draw a little bit longer like that. What is this called? All right. This is called a cuboid, right? You all know or not? This is called a cuboid. Can? So now, right, my cuboid I slice like that, slice, 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 slice. So I keep getting what? I keep getting rectangular, 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 right? So I keep getting this portion on top. All right, if I slice like that. All right, so the cuboid is also a prism. Because if you keep slicing, you must get the same area of the cross section. This makes it a what? This makes it a prism. All right, so all these are examples of a prism. Okay, nature, all this drawing, so easy to draw. Okay, how about this? This one, show you this one. Later you say that I draw things too easy one. Okay, like that one, with another one, is that side. This is how you draw three-dimensional drawing also. All right, good training for you. Okay, so I'm just teaching you how to draw three-dimensional here. Okay, you draw two of the same thing, and you join the corner like that. All right, like that also can. Can you see? So can you see? Okay, not okay, not too bad lah. Okay, we got ruler. Can you see this? This is also called a what? Remember to lock the meeting cake. Yes, thank you later lah. Now only 8 students only. Last time got more. Then now becomes like that. Hey, what happened? I think I must be talking too much. Too naggy, right? Maybe lah. Anyway, don't care about them. So down here, can you see or not? If I keep slicing downwards, all right, I keep slicing downwards. What do I get? I keep getting this shape down here. All right, I keep getting this shape. All right, I keep slicing downwards like that. I keep getting this shape. Can you see? So this is called the what? This is called the area of cross section like that. All right, which is the front part like that. Can you see now? All right, so if I keep slicing down like that, I keep getting the L-shaped thing. Can you see? So this, I don't know what shape is it. So how? I call it a prism, no? All right, I call it a prism. Okay? Because I don't know what L shape, how we call this. You know it's a cube, you know it's a cuboid, you know it's a cylinder, but what is this shape called? L-shaped three-dimensional shape. No lah, it's just called a prism. Okay? So you must understand what's the meaning of a prism. Okay? And the formulas for a prism. So we talk about volume. Volume is simply the area of cross section. All right, area of cross section times the what? Times the height or the depth. All right, or the depth, depending. All right, so down here, right? Down here, for instance, this shaded color, this portion here, this L shape, this is called the area of cross section. This portion here, I call it the what? Because it's a times inwards, right? So we call this a depth. All right, inwards is a depth. Down here, the cube, look at the cube. The on top is the what? The on top is the area of cross section. This portion we call it the height because it's a times downwards. Can you see now? So the downwards is called a height lah. So same as the cylinder, the downwards down here is called a what? This is called a height. Can you see? So the depth versus the height must know these two differences lah. Can? So it's either or. It's not must be both. It's either or. So it's the area of cross section. All right. If it's in front, you times the depth inwards. If it's on top, you times the height downwards. Okay. All right. So the volume is equal to area of cross section times the height or the depth. Okay. Then what about something else called the total surface area? Total surface area, right? I think it's useful to introduce you this formula. Total surface area is very long, all right, but bear with me. Total surface area is equal to perimeter of cross section. Perimeter of cross section. I write CS for short. CS means cross section. So perimeter of cross section times what? Times the depth or the height, depending. All right, depending. Plus what? Plus 2 area of cross section. All right, CS means cross section. All right, that is the total surface area of a prism. How to use? Later I show you. All right, just write this down first. Write this down first. All these are for what? Sec 1. Yes. Sec 2, Sec 2, chill. Don't be angry. All right, this is for you. Sec 2, right? Some of you haven't do this topic yet. All right, this topic is called mensuration. It's all about formulas and measurement. Very easy. Just put in the right numbers, know the formula, and bam, you get your answer. All right, for Sec 2, Sec 2, we talk about something called the cone. What is this? This is a cone. Question, question for Sec 1 and Sec 2. Is the cone a prism? No, a cone is not a prism. How come? Because the cone, if you keep slicing like that, what happens? The top will be like that, then you get bigger, then you get bigger. Can you see not? The size of the circle will be what? Different. So it's not consistent. But for the cylinder, if you keep slicing like that, you keep getting the circle. Can you see not? So if you keep getting the same area one, right, that's called a prism. But the cone is not a prism. Remember that. So this one is not a prism. All right. So there's a special formula for it. What's the special formula? The special formula for the volume is given as 1/3 pi r squared h. 1/3 pi r squared h. The pi r squared is actually the base area, pi r squared. And the h represents the height. Right? The h represents the height. The height is down here. All right, from the vertex, the highest point, this is called the vertex, the highest point of a cone, to the center down here. This is called the h down here. All right. So 1/3 pi r squared, the base, times height. Remember the fraction 1/3. Must remember the 1/3. All right. So that's the volume. Okay. Then the curve, or we call it the total surface area, TSA. All right. For short form, I write TSA. Total surface area is equal to pi r L. Oh no. Where's this L? Pi r L plus pi r squared. All right. Pi r squared is the what? Sure. What is the meaning of total surface area? Total surface area is the place that you can touch. So you can touch the top part of the cone, right? Which we call it the curved surface area. All right. This portion here, pi r L, right, is actually talking about the curved surface area. All right. Curved surface area. All right. So the cone, right, is made up of the curvy part. The top portion is the curvy part, and the bottom is a circle, which is pi r squared. So this is the base. Can you see not? This is the base area. So the meaning of total surface area means the place that you can touch. All right, you can touch the curvy part of the cone, which is given as pi r L, plus the bottom, which is a circle, pi r squared. What is L? L is actually this part here. L is actually what I call the slant height here, from here to here. All right, this is called L. All right, and L represents the what? L represents the slant height. SLANT height. So be very careful. There are two heights down here. One is the actual height, the one in yellow. All right, the one that is what? Touching the vertex to the center of the circle. That's called the actual height, H. And the other one is called the slant height. Usually we represent it as a L. Okay? So this is talking about the cone. What else? Another shape that is very common, right? Another shape that is very common is called the pyramid. So this is how the pyramid will look like. All right, 3-dimensional drawing. All right, is that it? Okay, this is called a pyramid. It's so ugly. Okay, let me redraw again. Okay, this is called a pyramid. So I link like that. Okay. Okay, pyramid, PYRAMID. Can you see that the pyramid and the cone got somewhat the same? It's like that one. It's like that one. So the formula is also quite similar. So the volume, VOL means volume, is also 1/3. Can you see not? So every time like that one, think of 1/3. So 1/3 what? 1/3 times base area times height. That is the volume of the pyramid. And in this case, right, the height, right? The height represents the what again? The height represents the center, the vertex coming down to the center of the square again, or the rectangle, or whatever shape. All right, this is the true height. This is the actual height. All right, so it's again, remember the idea 1/3 like that one. Cone is also like that, right? So it's 1/3 1/3 base area, base depending on the pyramid. If the base is a square, okay. If the base is a rectangle, then length times breadth All right, if the base is a 5-sided shape, can. Like 5-sided shape, remember not? 5-sided shape, we call it last lesson. Listening or not? Last lesson, 5-sided shape is called a pentagon. Six-sided hexagon. Yes, the base can be of different shapes one. So you have to adjust accordingly. That's why I say 1/3 times base area times height. Okay? And the total surface area, like, the total surface area for the pyramid, right, is simply find the sum of area of all the faces. Area of all faces. Right, you're just supposed to add them all up together. Okay, so we have volume of and the total surface. Volume and total surface. Can? Okay. Then last shape I want to show you is something called the, what is this called? This is called the ball, or we can call it the spear. Right, spear. So for a spear, right? For a spear, oh no, the line disappeared. Like that, like that, like that, like that, like that, like that. Okay, like that. Okay. For the spear, right, we just need to find out where is the radius. The radius is from the center to here. This is called the radius. From the center downwards down here is also called the radius. From the center to anywhere on the outside is called the radius. All right. So spear, right, is the spear a prism? No. Once again, if you cut, if I cut the spear, I cut like that, or I cut like that, all right, I will get like that, small, then becomes big, then becomes large, then becomes larger, then becomes big again, then becomes medium, then becomes small again. So the place the cut, right, the place where you cut must be of the same size one, but this one not the same size. So the cross section is totally different. This is not a prism, not a prism. So in Sec 2, right, yeah lah, you learn all the not a prism one. Sec 1, you learn all the prism one. All right, so that's how you differentiate if you want lah. All right, but must understand what's the meaning of prism lah. All right, after this lesson, please at least know that. So down here, what's the formula? Volume is equal to, of a sphere, very weird, is 4/3 pi r cube. The cube, right, is for the r. So it's r times r times r. 4/3 pi r cube. What is the total surface area of the sphere? Means the place that you can touch. Is actually 4 pi r square. All right, so these are the 3 more important formula you will learn in Sec 2. And Sec 1, just know what is the meaning of prism will do. All right, and the time now is to lock the classroom. Okay, where's my mouse? Okay, I just want to lock the classroom. Don't want any hackers to come in to show your weird things. Okay, so now the meeting is locked. So usually after, let's say, about 15 minutes into the lesson, right, I will lock it. So just now our lesson started at 6 o'clock. Now it's 6:17. More or less, those who want to come should have been here already, like you guys. All right, good job that you're still here with me. Let's go and look at question 1 together. The diagram shows a rectangle, PQRS, okay, of dimension. Dimension means what? The length and the breadth. All right, 11 cm. So down here I put 11 cm for the, 11 cm, I put it as for the length because it's the longer part, and 6 cm for the width. All right, so I put in as much information as possible into my diagram. So what happened? A semicircle of diameter 7. Okay, obviously this is the semicircle. And the diameter down here is 7 cm. Okay, can. And the quadrant is 6 cm. That means down here is 6 cm. Okay, which means that down here is also 6 cm. Okay, so what happened? Oh, do you want to find the perimeter of the shaded? Where is the perimeter? All right, perimeter is actually the outside. Where's the shaded? The shaded in this case is the blue color. So you're supposed to find here, the red color, here, plus here, plus here, plus here, plus here. All right. If you printed the worksheet on a white background, right, then it's very clear that we are looking for this red colored shaded portion. All right, because now my background is blue lah. So my background is blue, you might think that my shaded is in the white. Not true. Okay, so we are looking for the red color shaded. Let me be clear with you. Okay, so we are looking for the perimeter. Perimeter means what? The outside, right? Oh, so I need to know here. What's here? 7 plus 4 is 11, right? So down here is 4, 7, 8, 9, 10, 11. Hey, this side, PS. PS is what? PS is Plaza Singapura lah. No lah, just kidding. All right, PS down here is 6 cm. All right, and the bottom, S, that portion, the whole thing is 11. 11 minus 6, 5 cm. This one doesn't look like 5 cm, but it's okay lah, All right, it's okay. Don't worry. All right, they are just some raw numbers. Totally doesn't look like 5 cm. But it's okay. We know that the length is 11. We know that the quadrant down there is 6. The remaining must be 5. Don't care. All right, it's not drawn to scale. Don't worry about it. So The perimeter means that we have to find the what? The arc, the arc of the semicircle and the arc of the quadrant. Then +4, +6, +5. Can see or not? Okay, so let's slowly, let's go and find the arc of the semicircle first. So I can say the perimeter of semicircle's arc. Semicircle's arc. All right. That portion is called the arc, you know, that the curve things. All right. So how to find that? One entire circle, the circumference. How do you find the circumference? I always do not spell this word E-R-E-N-C. Circumference, right? Circumference is given as what? 2 pi r. That's for one full circle, or sometimes they write it as pi d. 2 radius give you 1 diameter. All right, circumference is 2 pi r or pi d. So down here, I'm giving the what? I'm given the 7 cm. 7 cm is the diameter, right? So I purposely use the what? Pi d one. This is a what? This is a semicircle. So it's half times what? Half times pi d lor. Can you see not? Pi d is the entire circle. All right, I just want half of it only. So it's half times pi d lor. And it's equal to half. And what's pi? Question wants me to have the pi as part of the answer. So don't touch the pi. Times pi. What's the d? D is a 7. So the pi don't touch. The pi don't touch. Half times 7. Half times 7 is a 3.5. Half times 7 is a 3.5. The pi, just put it behind. All right, 3.5 pi centimeter. Centimeter. Yo, scary. Centimeter. Okay, so that's the perimeter of the semicircle, the arc. Okay, how about the quadrant, the arc? Okay, perimeter. I'm doing it step by step so that you can actually present nicely. Of quadrant, I don't spell quadrant. Q-U-A-D-R-A-N-T. Quadrant's what? Arc. And a quadrant is what? Is it a full circle? No, it's a quarter of it. That's why it's called a quadrant. So it's a quarter of what? The entire circle. The entire circle can be written as pi d. But this is the what? This is the radius, right? So I purposely use my 2 pi r times 2 pi r because 2 pi r and pi d the same. All right, I'm just trying to use what I have. If they give me diameter, I use pi d lah. If they give me radius, I use 2 pi r. Can you see? No, just be flexible a little bit. It's the same thing. Don't worry. All right. So down here, I don't know my pi, so I just write 1/4 times 2 times pi. I don't know, and the radius here is the 6. So the pi I don't touch. The pi I don't touch. 1/4 times 2 times 6. So I purposely take 2 times 6. So can. 2 times 6 is a 12. 12 times 1/4 means 12 divided by 4 is a 3. Sure, press calculator yeah smart. Should have listened to you. So just press your calculator without the pi, you will still get 3 pi. Clear or not? Okay, so now you're looking for the what? You're looking for the perimeter of the red color portion. So how? So I will go in one direction. All right, I'll start off with P down here. So I go by the arc first. So perimeter of shaded. Just give the teacher the heading. Perimeter of shaded region is equal to, okay, the arc, which is 3.5 pi plus what? Plus 4 plus the quadrant. The quadrant is the 3 pi plus 5 plus 6. Can you see not? So I go in one direction, like primary school like that. Right? Whatever you learn in primary school is okay. Still can apply down here. So down here, the pi and pi you can plus together. They are the same family, right? All right. 3.5 plus 3 is a 6.5 pi. 6.5 pi. Then the numbers, right? The numbers we have plus 4 plus 5 plus 6. 4 plus 6 is 10. 10 plus 5 is 15. So you have a 15 plus 6.5 pi whole thing cm. Woohoo! Can you see not? It's in terms of the format that they want. They want it in bracket a plus b pi close bracket cm, right? So I'm giving them 15 plus 6.5 pi cm. Can you see now? Give it in the format that they want. Don't have to press your pi. Can you see? Yeah. But remember, pi and pi, then you can put together. Number and number you put together. Clear? All right. And that is question 1. Let's go on to question number 2. All right. Let's take a look. What is this? Trapezium. All right. Trapezium. PQRS is an isosceles trapezium. What is isosceles trapezium? It means that down here is equal to down here. All right. It also means that the white line, right? The white line, if I cut down here, right? If I cut downwards here, All right, down here. Down here will also be 12 cm. Okay, and if PA down here is 5 cm, it means that down here is also 5 cm. If on top down here is a 10 cm, right? Down here is also from A to here is also a 10 cm. Can you see now? So isosceles means they are the left and the right part, they are the same one. All right. So understand? Okay. So anyway, what else? They say that PS is equal to QR. PS is equal to QR. There, I told you already what. All right. They are the same. So this one and this one is the same. What else? Is perpendicular height is 12 cm. Okay. SR is 10. Okay. PA is 5. Okay. B is a point on PQ. Okay. Such that RB, the black line, is equal to QR. Oh, is equal to 13. Oh, that means down here is 13. So weird. Never mind. Clues for me, better right. So this is 13 cm. The black line is 13 cm. And the corner down here is 13 cm also, R cube. RQ and PS the same also. That means this is also 13 cm. Okay. So the area of triangle RBQ, the area of this triangle here, RBQ here, is equal to 60. Oh, so what? All right. Anyway, it's information for me. Don't complain. It is also given at SCB. Oh, down here is 90. SCB down here. Down here is 90. Okay. So what? State the geometrical name of the quadrilateral PBRS. The meaning of quadrilateral means a four-sided shape. So PBRS. What is this four-sided shape called? The special name of PBRS? Right. Yes. Very good. Some of you write parallelogram, correct, and you spell perfectly. Very good job. So A, the answer is parallelogram. PARALLELOGRAM. Please, must learn how to spell. Because sometimes the question will ask you like that one. All right, then you know, but you don't know how to spell. Your teacher will mark you wrong. All right, things like parallelogram, rhombus, trapezium, must know how to spell. Okay? All right, so the answer for A is parallelogram. Part B. Calculate the area of the PBRS, which is the parallelogram. How? Area of parallelogram. All right, area of parallelogram. What's the formula? It's actually simply what? It's actually base times what? Base times the perpendicular height. Perpendicular height. All right. So looking at this parallelogram, it's like that. You can see now. For example, it's like that. All right, I draw a bit fatter one. So I purposely, right, where's the base? The base is actually here. Right? I call this the base. Can? And where's the perpendicular height? The perpendicular height is down here. Can you see now? It must be perpendicular to the base down here. All right, this is called the perpendicular height. So simply take the base times the perpendicular height. Can you see something? It's actually what? If I take my scissors and I cut this portion out, here, and I stick it down here. It appears here. Can you see not? It becomes like a what? It becomes like a rectangle. Rectangle simply means what? Length times breadth. Can you see not? So a parallelogram is like the what? The grandfather of a rectangle. All right. So it's simply what? Base times perpendicular height. If you know how to cut, it's actually very simple. Nothing difficult. So in this case, what's the base? The base is 10, right? 10 cm. 10 times what? What's the perpendicular height? 12 lah. 10 times 12? Yeah lah. So simple. Yeah lah. Answer is 120 cm square. Woo! I got it. Can you see? So it's not difficult. All right. Area of parallelogram, base times perpendicular height. Cool. That's it. Moving on. What's next? Find the length of SC. Where's SC? Oh, SC is this orange, this beige line down here. SC. Now it's white color. Right. So SC. How to find SC? Isn't PBSR is a parallelogram? All right. So, so if now this is the, we're still talking about the parallelogram, All right. If I call this my what? If I call this my base, is it true that my SR, is it true my SC, sorry, not SR, is it true my SC right down here is the perpendicular height? Oh yeah, can you see not? This SC. So instead of calling, right, just now, instead of calling my base as like that, the horizontal line, and my height as this, what happens now? My base is the one that is slanted, And my perpendicular height is the one that is the dotted line one. So in this case, right, if I cut off this portion and I stick it, I stick it here, it goes back to a what again? It goes back to a rectangle again. Can you see or not? So now my base is BR. My base is BR. Can you see? And we are talking about the same what? The parallelogram is the same, right? This question, the parallelogram is 120. This question, the parallelogram, the area, must also be 120 because we are talking about the same parallelogram. Okay, so that's the clue. So I write area of parallelogram. Area of parallelogram is equal to what? Area of parallelogram is equal to, just now I found already. What's the answer? 120 centimeter square. 120 square centimeter. Okay, and how do you find the formula? What's the formula for area of parallelogram? Simply base times perpendicular height. Base times perpendicular height. Can you see that every time, right, when it comes to formula, right, I will tend to write it out one. Can you see or not? So every time I write, right, my finger actually remember the formula. Wow, that is a level up for math, man. All right, your brain don't have to think, but your fingers can write out the formula just like that. Because if you keep practicing, such things will happen. Okay? So what's the base? The base, we're looking at this portion here already. This is P, right? That we are talking about here. So the base now we call it what? We call it BR. All right, base is the BR times the perpendicular height. The 90 degrees is here, right? The 90 degrees is your SC, so times SC. It must give you 120, all right? It must give you 120. And the question is looking for SC. Can you see that you are actually forming an equation? You're forming an equation to find what? To find SC. Can? What is BR? BR is what? Look at the question. BR, oh yeah, BR is RB, is 13. So RB, BR is 13, all right? 13 times what? 13 times SC. 13 times SC will give you 120. SC will be equal to what? Times 13 bring across, 120 divided by 13. And down here, you can conclude by saying that SC is equal to, press your calculator, all right? Sec 1, Sec 2 can press calculator, don't be shy. 120 divided by 13 will give you a 9 and 3 over 13 what? Centimeter. And that's your answer. All right, so usually I'll write it as a what? Usually I'll write it as a fraction. It's more accurate. All right, if you can give the most exact, accurate answer, why not? Then don't have to give to 3SF. All right, this can be put as a fraction, means what? Means that it is a rational number. All right, rational means what? Can be put it as a fraction. Those irrational, then you give it to 3 significant figure. All right, by default, default. All right, so down here you can give as a fraction. Always give as a fraction. Why? Fraction is the most exact answer. So that's the answer. 9 and 3 over 13 centimeter. That's your SC. So learn how to form your own equation. All right. So every question got link one. Just to let you know. So A is to introduce what is a parallelogram. B is to test you on the formula for parallelogram. C is allows you to what? Manipulate the formula a little bit, put into another equation to solve for another perpendicular height. Can you see now? So you must understand all this, right, is set up nicely for you. Okay? All right, what's the next one? Next one, they are looking for the length of PQ. Where's PQ? PQ is this whole thing. Just now I thought down here is 5, then down here I cut, right? Down here is also 5, right? Then on top here is 10, down here is 10. Oh, 20 cm lah, answer. Correct lah. This is a free question for you, all right? But Cher, how come the area of triangle I haven't used yet? Okay. Can we try to use that then? All right. So how to use that? I also don't know. They tell me that this whole thing, right, is 60. So what is 60? All right. I know that the height is 12. So maybe can I use the what? Manipulation of the formula to assist me. Okay, let's try. Area of triangle. All right. I try to form my own equation. Second time. Area of triangle, the question tells me is 60 square centimeter. Okay, then area of triangle is given as half times base times height. Again, writing out the formula, all right, so that you can have something to compare against, equal to 60 square centimeter. What is the base? Base, for instance, BQ, I don't know. Half times what? The base is called BQ. I don't know, I write BQ. Times the height. The height is the what? height is the 12 cm, is equal to 60. Can you see? So my objective, let me go and find BQ for fun. So anything times on one side you bring across is a divide. 60 is already here. Don't disturb the 60. 60 divide by half times 12, bring across, divide by 12 also. Write everything together. Don't be afraid. Can one. Then do what next? Press calculator lah. 60 divided by half, divide by 12. You get a 10 centimeter. So we know that BQ here is what? BQ here is a 10 centimeter, right? And we know that SR and what? And PB are what? Are sides of a parallelogram. So on top is 10 cm, below is also 10 cm. What? That's why it's still 20 cm. Can you see or not? Okay, what? So down here you can say that PQ is simply what? Is simply 10 cm plus 10 cm is equal to 20 cm. All right. So actually, if they don't give me the area, right, I still can find. How come? This is a isosceles trapezium. So you must look for the keywords. All these keywords are there to assist you. Okay? All right. And that is for question 2. Can I? All right. Moving on. Question 3. What is this? Hey, again, if you think that I'm going too fast, right, it's okay. All right. The answers, right, all these answers, right, you can actually take a picture, lah, right? You have your handphone, take a picture. If cannot, don't worry, go on to our website. All right, 2 days later, we should upload it in 2 days' time. All right, this lesson will be uploaded into our website under the live courses, under the past lessons. All right, then you go and look for Sec 1, Sec 2, this topic, and you can, they will bring you to a YouTube portion. Then you can watch the lesson again. All right, then there's the place that you can pause and you can write down the workings at your own time, at your own pace. Okay? All right, let's move on. So down here, what do you have? Diagram shows a skateboard ramp that's coming out from a park. Okay, you know those skateboard, you know those tricks that you all do? Okay, never mind. Calculate the volume. Volume means what? Everything. Hey, what is this? Is this a prism? That's my question. Is this a prism? Yes, it is. Take a knife and you cut downwards. If you cut downwards, right, you keep getting a what? You keep getting a this shape. You take a knife and you cut downwards. You keep getting this shape. You take a knife and you cut downwards. You keep getting this shape. What is this shape? This is called a trapezium. How to spell? Must know. Trapezium. And the question give these two lines, right, means they are of the same length. This is a isosceles trapezium. Wow, you are learning how to name all these shapes really. Good job for you. You can see? Okay, so you need to find the volume of the ramp. Prism. Prism. Okay, how to find the volume of a prism? Volume of prism. All right, or you can write volume of ramp, which you know that is a prism. All right, is given as what? Area of cross section. Area of cross section times what? Area of cross section times the depth or the height. In this case, what? Because in front here is the cross section. This portion is called the what? Inwards, what? That's called the depth. Okay? So area of cross section times the depth. And the cross section here, what is this shape? It's a trapezium. It's a trapezium. So what's the formula for a trapezium? Okay, this one you have to know. Write it down for you. I write in red color some more. Area of a trapezium is given as half times sum of parallel lines. All right, area of trapezium is given as half times sum of parallel lines. All right, times the height. This portion is just on the what? This portion here is just on the area of trapezium, right? Which is the area of cross section. They are the same. All right. So the depth is outside. It's still outside here. That's why you must understand all these keywords that we are talking about. Okay. So for a trapezium, right? For a trapezium, okay, my trapezium is down here. Where's my height? My height is actually down here, which is 90 degrees to the ground. And the two parallel lines on top and below, they are parallel, what? Okay, that's the property of a trapezium. One pair of parallel lines. Can we split the trapeziums into a rectangle and two triangles? Jethro, good idea. Good idea. You can do it, no problem. But I don't like it. Why? Because if you split them up like a rectangle and two triangles, right? A little bit like primary school mathematics, A little bit like primary 5, primary 6. You cut things up, right? always cut things up, right? So secondary school, really, come on, let's learn a little bit more what? More straight to the point, the formula, get to the answer immediately. Those type of method. All right, so this method, right, is the area of trapezium. You can use it, it will work for a trapezium. So it's like directly to the point. Can you see or not? All right, instead of finding rectangle, then you must find triangle. Then times 2, then you plus everything. It's like 3 steps, you know, instead of just putting it into 1. Can you see? All right, so you can, all right, I'm not saying that it's wrong. You can, but I prefer the straight to the point method. All right, because in exam, you must know also, time is a key factor. Ayo, no time, no time to finish. Where got no time to finish? You are using the long way, that's why got no time to finish lah. Can you see or not? All right, anyway, it's perfectly okay, I just to say. All right, but I like to use the formula just to introduce you. So the height is the perpendicular, all right, height, and the parallel line is what? On top is 2 meter, down here is 2 meter, and below is 10 meter. Can you see? So that is the parallel line. Good job, thank you. All right, and the height, the height is what? The height is 3 meter. So you see, I got all the information. Nice. Okay, let me apply it in. Half, just write half, times, what is the sum of parallel line? On top is 2, below is 10. So it's like 2 plus 10, no? Sum means what? Plus, 2 plus 10. Times height. What's the height? The height is a 3. Okay. Nah? This gives you the area of the trapezium already, immediately. All right, so it's like half times 2 plus 10 is a 12 times 3. 18, no? So down here is the area of the trapezium. But wait, you're looking for the volume of the entire thing. So the area of the front is 18 times the depth in. Depth in is 30 meters. 18 must times 30. Can you see now? You must be very clear what you're looking for. One step at a time. So 18 times 30, press your calculator lah. Ayo. Answer is 540. All right, some of you say that, my teacher do not allow me to use the calculator. In Sec 1, I understand. All right, but in the final year examination, right, your teacher should have allowed you to use the calculator already. All right, Sec 1, 2, 3, 4 should be able to use your calculator. So get to know your best friend well. This is your best friend. All right, I got a few best friends. All right, all these are my best friend. Okay? So learn how to use your calculator very well. All right, that's very important. 540, is that answer? Yes, but remember to put in your units. Units is what? Meter cube, because we are talking about volume here. Ta-da! Can see or not? All right, so volume of prism, area of cross-section times the depth or the height depending. Okay? All right, let's move on. Calculate the mass of this ramp. And the clue is 1 meter cube. 1 meter cube weighs 20 kg. Easy lah. Let's take a look at how heavy or what is the volume of the ramp. The volume of the ramp is 540. So 540 meter cube is how much? Huh? So easy. Yeah lah. So from 1, how to get to 540? Times 540. So 20 kg times 540. All right, you can just press your calculator and multiply once again. 540. Oh no. 540 times 20. Answer is 10,800 watt. The units must write kg. And that's your answer. Okay? So simple question like this, take and go. Go what? To next question. All right. If this ramp is to be painted, calculate the cost of painting all the external surface, including the base, if the cost of painting is $3.50 per meter squared. So this is asking you to find the what? To find the place that you can touch. The place that you can touch for this ramp, which is the what? Total surface area. All right. Total surface area. This is a prism. So I can write total surface area of ramp. All right, of ramp is actually a prism. Okay, this ramp is a prism. Is equal to what? The formula, perimeter of cross section. Perimeter of cross section times the depth or the height. This one, right? This portion here in front is called the what? It's called the front part, right? This portion is called the depth. All right, so we call it the depth. So perimeter of cross section times depth plus what? Plus 2 area of cross section. Okay, this question I want to talk a little bit about the total surface area. Hopefully you can understand better. All right. So understand the formula will be great. So I'm going to use different color. Ready? So we know that the cross section is this portion here. Let me use red down here. Can you see down here red on top and red below here? All right, and the two lines that slanted down, I'm going to use white. So here is white and white. Can you see the color? And this long 30 meter, long 30 meter, I'm going to use green. Can you see here? All right, this portion is going to be go green. So can you see the color coding? All right, the red, white, red, white. So now, right, I purposely take a scissors, right? I take a scissors and I cut along the green portion. All right, I cut along the green portion, and I will get something like that. All right, I cut along the green portion and I flatten it. If I flatten it, right, I will get something like that. I will get the red color portion below, which is the 10 meter. All right, I flatten it, followed by the white color portion, which is the 5 meter, followed by the top portion, the red color portion, which is the 2 meter, followed by another white color portion, which is another 5 meter. Can you see or not? So I purposely cut at the green color line. All right, this imagine that is made of paper This prism I cut at the white color line, and I open up and I flatten it. Open up and flatten it, so it looks something like this. All right, whereby the green color is down here. Right, this green color and this green color will meet. Can you see? Can you do some imagination? Can? So if I do that, right, I cut and I flatten and I pull it, right, what happened? It becomes a what? Can you see that this one becomes a what? It becomes a rectangle. Do you know that? It becomes like a rectangle down here. It is a rectangle. All right. That's why the formula is so beautiful. It asks you to find the what? It asks you to find the perimeter of the cross section. Means that you're supposed to add up all this. This is called the perimeter of the cross section. Can you see or not? The cross section is made up of the red, white, white. So you're taking 2 plus 5 plus 10 plus 5. Isn't it the same? 2 plus 5 plus 5 plus 10. So you're taking the perimeter of the cross section. This is the perimeter. All right, 10 plus 10, this is 22 cm. All right, this 22 cm. All right, that's called the perimeter of the cross section, which is this part. You take what? You take 10 plus 5 plus 2 plus 5, perimeter of cross section, times what? Times the depth. All right, times the depth. What's the depth? The depth is the green color line, which is the 30 meter here. All right, times 30. Can you see now? You're actually trying to flatten it to make it a rectangular piece. So you take the length times breadth So must do some imagination. That will give you the what? That will give you all the faces of the trapezium. That will give you the top, the slanting part, the bottom part, and the slanting part again. It will give you the 4 faces of the trapezium. Then plus what? Questions, the formula says plus what? Plus 2 area of the cross section. Where is the area of the cross section? Isn't this the area of cross section? Which you haven't counted in yet, what? The front and the back. So the rectangular piece, right, is you flatten, right, is the top, the slanting, the bottom, and the slanting again. Those 4 faces. But the front and the back, you haven't covered. That's why must plus what? 2 area of cross section, which just now I found already. Just now I found. What's the area of cross section? Which is the trapezium, right? Which is the 18 one. Can you see? From my volume, I found the area of cross section, which is 18. All right. So down here, I just put 18 inside. So that is the reason for this formula. Perimeter of cross section times depth plus 2 area of cross section. If you can understand this, perfect. All right. If you can understand the formula, perfect. But if you cannot, just memorize the formula. I know that's not a very good way of teaching. All right. But if you can understand, it will be good. Okay. If cannot, just remember. Okay. So you calculate 10 plus 5 plus 5 plus 2 is 22. Right. 22 times 30. This portion will be 660. Plus what? 2 of 18. 2 times 18 is 36. So 660 plus 36. Answer will be a 696. Yeah, that's the answer. Woo! Is it? Is it? Meter. 696 meter square. Is it the answer? Wait. The question is asking about painting. So, per meter square, what's the meaning of per meter square? It means 1 meter square is how much? Right? It means that 1 meter square is $3.50. You got what? You got 696 meter square. You times 696 on one side. Remember to times 696 on the other side. Right? And your answer would be 696 times $3.50. $2,436. So the answer here will be $2,436. $2,436. Correct. Can you see? Okay. So that is how you do it. Right? Must understand a little bit of the prism. I think it's important. All right. So sometimes you learn to cut and flatten it. You can see that it's a one big piece of rectangle. It's easier. Imagine the L-shaped one. You remember the one I draw? This one? This is still okay. This one. Oh, where is it? Okay, this one. Right, the L-shaped one, this one is still okay. But imagine they have a lot of layers one like this. Like this one. Sometimes that one, like a different steps one. Oh my goodness. Oh my goodness. Oh my goodness. Can you see not? Different steps one. Alright, then this one is a prism also. Right, and you're supposed to count every face, every faces. Oh my goodness. I also scared of drawing, man. Alright, then you join them. Oh my goodness. I also don't want to draw this, man. Alright, so imagine if you got something like that and they have many faces. Oh my goodness. If you're going to find every one, right, one by one, you go crazy, lor. That's why the formula comes in strong. If you can understand, you go and plus the what? Plus the perimeter of the cross section times the depth in. Wow, it's actually one big piece of rectangle already. Then you plus the front and the back, the area. Then that will give you the total surface area. Can you see? Do appreciate the formula. I think it's very, very useful. All right, if you can understand. Okay, and try to understand, of course. All right, let's go on to question number 4. All right, for this exercise of mensuration, we have 5 questions. Okay, so question 4, 2 more. Bear with me, you can do it. Come on. So the diagram shows 2 objects. One is X is a cylinder. Cylinder is a prism. And Y is a cuboid. Cuboid is a prism. Okay. The cylinder has a height of 20 cm. So I like to put in information. This is 20 cm. So what? Base radius of 14. So down here is 14 cm. And it's filled with oil. Okay. Pi is 2207. Very good. Question gives you pi as 2207. You take it. All right. If the question never if the question never say, use your calculator's pi. All right. You must give the pi down here. It's 3.141592654. Use your calculator's one. You're supposed to calculate the volume of oil in the cylinder. The question says that the oil fills up the cylinder. So you just find the volume of the cylinder will be the volume of the oil, right? Yes. So volume of cylinder, all right, volume of oil in cylinder is the same as the volume of cylinder, all right, because it is totally filled up, right? So cylinder formula for volume? Yes. Area of cross-section times height. Correct or not? It's a prism, what? Area of cross-section in this case is the circle, right? Pi r square lah. Yeah, that's why the formula links back to your general way of writing the formula. All right. Area of cross-section in this case is a circle. Circle is given as pi r squared times h. So we remember it as pi r squared times h for the cylinder. Can you see now? Pi r squared times h. Okay? Or you can think of it as the area of cross-section, which is the circle, area of the circle times the height. Same thing. Area of circle is still pi r squared 1. So pi is given as what? 22/7. The radius, this one's so easy, I know. 14 squared times height is 20. Just press your calculator accordingly. Let's go. 22/7 times 14 times 14 times 20. Answer, bam. 12320. Volume, cm cube. cm cube. And that's your answer. Can you see not? It's the exact answer. Keep it as your exact answer. Don't try to round off to whatever significant figure or what. Exact answer is the best. You're talking about math here. Math is talking about accuracy. So if you can, always give the exact answer. Can? What's next? Part B. The volume of the cylinder is the same as the volume of the cuboid. Very good. That means the volume down here is what? Volume is the same as just now, which is what? 1,2,320 cm cube. That's the volume of this cuboid also. Because question says same what? What's next? The area of ABCD is a square. Oh, it's a square. So ABCD down here, the white color portion, can you see? Down here is a square, and it has an area of 256 cm square. Okay. Find the length of PD. Hey, easy. So again, write out the what? Write out the volume. Write out the formula for the volume of what? The focus here is the cuboid. And what is the volume of cuboid? Length times breadth times height. All right, you can write that. Length times breadth times height. All right. This height, right, you can exchange it for what? You can actually exchange it for something called the depth. All right. Yeah, my depth spell already. Depth. You can exchange it for the depth. Depth means what? That means like the inwards lah. All right. Length times breadth, can we call it like the area of the base down here? All right. Area, which is what? 256 is given, right? So this length times breadth, we can call it this portion here, the white color shaded one, times the depth. PD is the depth lah. Cannot? Can. Ultimately, you need the three numbers to times, right? Length times breadth and height. So in this case, right, we can call this the 256. Right? Length times breadth. In this case, we call it the area of the side times the depth. The depth, we call it what? PD. Can? All right. So it's the one face times the depth in. And this will give you the volume of 1,2,320. Can you see not? So once again, you are learning how to form the equation with the clues that you have. How to find PD? Question, want to find PD, right? So times 256, you bring across. The 1,2,320 is already here. Don't disturb. Times 256 becomes divided by 256. Do what next? Panic? No lah, press calculator. All right. 1,2,320 divided by 256. Answer is 48.125. So PD is equal to 48.125 centimeter. All right. The 0.125, please write. Please write it now. All right. Don't say round off. Don't have to round off. This is the exact answer. Give it as 48.125 cm. Don't change it. Cool? So that is the length of PD. All right. That's the depth, we call it here. All right. And moving on, what's next? Calculate the total surface area of both objects. Oh, okay, what? So let's go and find the cylinder first. Cylinder is a what? Prism. Very good. Okay, very good. So total surface area, I'm going to call it TSA. Lazy to write out. Total surface area is equal to what? It's actually the perimeter of cross section. So down here, this yellow color portion is called the what? It's called the perimeter of the cross section. Cross section is the what? A circle, right? So perimeter is what? 2 pi r. Can you see not? 2 pi r is like the circumference of the circle. That's called the perimeter. Correct? So perimeter of cross section times what? Times the height. Right? Perimeter of cross section times the height. Then do what? Remember? Then do what? Plus 2 area of the cross section, which is the top and the bottom. All right, plus area of the cross section, top and the bottom. And on top is a circle, so it's times 2 pi r square. Can you see now? Isn't this the formula for volume? Isn't this a formula for total surface area of cylinder? Let me check. All right, so I go back to my just now the formulas here. All right. Oh, the cylinder down here I never write. All right, but it's supposed to be. Volume of cylinder is pi r squared h. Total surface area of cylinder is 2 pi r h plus 2 pi r squared. All right, that is the total surface area of the cylinder. 2 pi r h plus 2 pi r squared. If you want shortcut, you can memorize this formula. All right, but it will be best if you can understand the what? The total surface area of the prism. Perimeter of cross section times height or depth plus 2 area of cross section, the front and the back. Okay? Okay, so now you put in the numbers. What is pi? Pi is 2207. What's the radius of the cylinder? Radius is 14. What is the height of the cylinder? Height of the cylinder is a 20 plus 2 pi r squared. Pi is a 22/7. Radius of the cylinder is a 14 square. So down here, you can put a bracket. If not, it's very safe also. Don't worry. Press everything into your calculator from left to right. Let's go. 2 times 22/7 times 14 times 20 plus 2 times 22/7 times 14 square. Answer, beautiful number, 2992. 2992 what? Centimeter square. This is for the total surface area of the cylinder. Cuboid leh? Don't worry. So we have total surface area of cuboid is equal to what? It's equal to, you want to do the primary school method? Can? Primary school method, you have to find down here. This one, the front. The top. Well, luckily the base, right, down here is a square base. So all four sides, right, the sides is of the same thing, luckily. And we know that from the previous question, right, the area is 256. So the area of the square, right, area of square ABCD is equal to 256 cm squared. So what is the side? What is AD? We know that AD is equal to AB, which is equal to BC, which is equal to DC. How to find one side? What times what give you 256? So it's actually talking about square root of 256. Right? So what times what equal to 256? So it's actually talking about square root of 256. Square root of 256 is actually equal to 16 cm. All right? For the Sec 2 student, you must include your plus and minus 16 like that. All right? Because every time when you square root, right, you must also include your minus. For Sec 1, if you don't understand, it's perfectly okay. But Sec 2, standard, you must write your plus minus 16 every time you square root. So for instance, square root of 25, you cannot say 5. You must say plus and minus 5. Square root of 256, you cannot say 16. You must say plus and minus 16. This is to be more exact. And down here, you give a final conclusion. All right, you're taking 16 centimeter, and the negative 16, you have to reject it. All right, so Sec 1, in future, you have to do all this. All right, there are two answers given to you. You're supposed to reject one of them. All right, I saw a thumbs up from Hi. Good for you. So 16 cm is one side. 16 cm is one side. So down here is like 16. All right. Then the long part, long part is just now previous. Previous side is 48.125. So down here, the length is 48.125. And there are 4 pieces of it. 4 pieces of it. So I go by writing 4 pieces of what? 16 times 48.125. Remember, I'm looking for my total surface area. Total surface area is the place that I can touch. All right, the long rectangular 4 pieces, it so happens that it's a square portion. All right, means that all the sides are of the same thing. So 4 pieces of 16 times 48.125. Where do I get the 48.125? It's actually from the previous question, PD. Right, PD is the long one, right? 48.125. As I say, all the question got linked one. Okay? All right, so this one is the sides plus what? Plus the front and the back, right? In front is 256. At the back is also 256. That's the area, right? Yeah, lor. So you can do like that also. You can do that also. All right, you can do like one by one. Okay, find the top, find the left, find the bottom, find the right, plus together, find the standing on the left, and find the standing on the right. So you can slowly do, lor. But do you want that? If you can do faster, come on. So down here, 4 times 16 times 48.125. All right, plus 256 plus 256. 3592. 3592 what? Cm square. Okay. So now they want to find the total surface area of both objects, right? So you plus them together, lor. All right. So you plus these two items together. Total surface area is equal to total surface area of both objects is equal to 2992 plus 3592. All right. So 2992 plus 3592. Answer is 6584. 6584 what? Cm square. Answer. Ta-da. Can? All right. So you can find individual, or you can actually use the formula again. Perimeter of cross section, all right, means that 16 plus 16 plus 16 plus 16, all right, times the depth in times 48.125. All right, so if you can see, 16 plus 16 plus 16 plus 16, right, times the depth in 48.125, that will be 3080. All right, that is actually the 4 rectangular faces. Then you plus the 256 plus 256. Answer is still 3592 for the total surface area of the cuboid. Same one. Okay, but must understand the formula. Then it will help you very, very much. Okay? All right, so this one is all the Sec 1 revision, all right? For the Sec 2 is our Sec 1 revision. For the Sec 1, this is your main topic in your secondary 1 syllabus, all right? The next question, we'll be talking a little bit about the Sec 2 syllabus really. All right, just one question, quick one. All right, here, as you can see, the top portion is called a cone. And the bottom, it's like a ball, right? But it's not a full ball. This is called half a ball. This is called a hemisphere. Hemisphere is half of a ball. All right, for sure, I call it hemi. This one I call it a pyramid. All right, it's a, I don't know what is the base. Is it a square base? Is it a rectangular base? I need to read the question. Thank you, hi. So, figure P shows a solid P, the one with the cone and the hemisphere, is made up of a cone and hemi. The height and radius of the base is 8 cm and 6 cm. So the height and respectively, do you know what's mean of respectively? Must know this word. Respectively means what? It means that the first number, 8 cm, represents the first item, which is the height. The second number, 6 cm, represents the second item, the radius. So the radius here is a 6 cm. All right, and the height down there is a what? The height down here, the actual height here is a 8 cm. Okay, so H height is from the vertex down to the center of the circle, which is slightly on top P lah. Okay, and wait, the solid is then melted. All right, so it must be made of metal, melted down to form a square pyramid. Oh, it means that the bottom of this pyramid, right? Sorry, is a square. Means that the sides are the same lah. With a base of side 10 cm. Oh, so 10 cm by 10 cm. Oh, and pi is 22/7. Okay, pi is taken as 22/7. Find the volume of the solid P. Very straightforward. Solid P is made up of a what? It's made up of a cone and it's also made up of a hemisphere. So the formula comes in. So we combine everything together. Volume of solid P is actually made up of the volume of cone plus what? Plus the volume of a hemisphere. All right. So at this moment, right, I'm just writing out the idea. The idea is to take these two items plus together lah. Next, I'm going to write out the formula. Volume of cone, because it's this shape, this shape, 1/3. Your 1/3 must come out. 1/3 pi r square h. Volume of a cone plus what? Hemi. Remember just now, a total sphere. Total sphere, right? The full thing, right? The full ball, this is called a sphere. The volume is given as 4/3 pi r cube. Half of it, that's called hemi lah. So half of 4/3 is what? 1/2 half times 4/3. 2/3. So the volume of the hemisphere is 2/3 pi r cube. So you must be able to derive the hemisphere formula from the sphere's formula. So now you put in all the numbers. Pi, what is pi? Pi, question say is 22/7. Just put it in. Radius of the cone is what? 6. Square. The height is 8. Plus 2/3. Pi is what? 22/7. And what is the radius of the hemisphere? The radius of the hemisphere and the radius of the cone, right? The same, because the cone is sitting on top of the hemisphere. So in this case, it's still 6 cube. And press everything in your calculator. No fear. Go. 1/3 times 22/7 times 6 square times 8 plus 2/3. Oh no. Plus 2/3 times 22/7 times 6 cube. Answer. You will get a fraction answer, which is 754/2/7. 754/2/7 what? Cm cube. If you can give your answer as a fraction, it's okay. Don't worry. All right, it's okay one. This is the most exact answer. Why not? Take it. Take it. Can? And this is your answer, lor. And key everything in your calculator. Key properly, please. Sometimes you key wrongly. That's why answer is wrong lah. Then you know that one question will affect the next question. Or sometimes when you read the answer, your eye got a little bit of certain things at the side of your eyes to make it a little bit blurred. Then you copy wrongly. Then again you minus marks. So please copy the number correctly. Okay. Moving on. What's next? All right. Find the height of the pyramid. Remember, the volume of this cone and hemisphere, right, is being melted down to form the pyramid, right? So we know the volume of the pyramid, which is the same as the cone plus the hemisphere, which is 754 2/7. So I'm going to form my own equation. Volume of pyramid must be from the volume of the cone and the hemisphere, right? Because it's a link. A and B, they are linked. So you are supposed to use your A answer to assist you in your B. It's always like that one. All right. So volume of pyramid is equal to what? 1/3 times what? 1/3 times base area times height. This is the formula for the volume of pyramid. Correct? All right. Remember, it's this shape one. Pyramid. So it's 1/3. So the volume of pyramid is the same as the volume of the hemisphere plus the cone, right? Yes. Thank you. Hi. All right. So my 7, 5, 4, 2/7, I purposely put under the volume of pyramid. Right? Because when you melt it, it becomes liquid. Right? Metal, when you melt it, it becomes liquid. And you put in the mold to make the pyramid. So all the liquid, right, is being transferred to the pyramid already. Okay? And the question say that what? All right, is used to melt to form the pyramid. So everything that is in the cone and the hemisphere is being used up in the square pyramid. So this volume is equal to 1/3. What is the base area of the pyramid? Yes, it's a square base and it is 10 cm. Very good. So the base area is like 10 times 10. And the height, I don't know. Isn't that what you are supposed to find? You are supposed to find the height of the pyramid, what? So now what you do? Yes, you got all the information, only don't have the height. So how? Times, if you bring across the equal sign, becomes a divide. So your 754 and 2/7 is still here. Times 1/3, bring across, divide by 1/3. Times 10 is 100. Bring across, divide by 100. Just press into your calculator. Nothing to fear. And this 754 2/7 is still in my calculator. So I'm going to press divide by 1/3. Divide by 100. Answer. I will get a 22 and 22/35. So the height is given as 22 and 22/35 what? Centimeter. Write it as a fraction if you can. This is once again the exact value. All right, always have the exact value here. That will be the best. Okay. Okay, last question, ready? All right, question 5C is the last question. Then we can go and have our dinner already. All right, hi, thank you, clap. All right, the rest, good. All right, find the total surface area of the solid shown in figure P. Okay, so don't care about the pyramid already. You're talking about the total surface area of the cone and the hemisphere. What's the meaning of total surface area? The place you can touch. The place you can touch, which means the curvy part down here. The curvy part, all right? The bottom not counted, right? Because the cone and the hemisphere stick together. So you cannot touch the inside. You cannot touch the circle down here. You cannot touch the white color portion. Can you see now? So you can touch the curvy part and the curved surface area of the hemisphere. So let me write out first. Total surface area of what? Of figure P is actually made up of the curved surface area of cone plus what? Plus the curved surface area of the hemisphere. Curved surface area of hemisphere. Can? Okay, so what is the curved surface area of the cone? It's given as pi RL. Pi RL. All right, pi RL. And we got a problem here. We don't know what's L. Later. How to find the curved surface area of the hemisphere? Nothing to worry. Remember just now the full sphere? Right, the total surface area of the sphere, right, is given as 4 pi r squared. This is one of the formula. 4 pi r squared is the whole thing. So half of it, the curvy part is simply 2 pi r squared. All right, half of 4, isn't it a 2? All right, so now let's go and worry about the L. How to find the L? Where is the L in the first place? L is this portion here, the slant height. L is considered the slant height. All right, so maybe, right, you can tell a teacher at the side, let L be the slant height. All right, so that you can bring in the alphabet L, so that your teacher understand. And just now we have the clue. We have the height of the cone is what? The height, the actual height is 8 cm. And the radius, radius is 6 cm. So the radius is the one in red color. I need to contrast it. So down here, red color, down here is 6 cm. And this is a 90 degrees. For Sec 2, you learned this already. For Sec 1, haven't, but don't worry. All right, just know for now, just for fun. All right, this is something called Pythagoras theorem. A right angle triangle, you activate Pythagoras theorem to find the length. So the short square, which is the 6 square, plus the medium length, 8 square, must give you the longest square. All right, L, which is the hypotenuse. We call L as the hypotenuse, the longest side of a right angle triangle. All right, so this is something called Pythagoras theorem. All right, so I hope that you have learned this already. All right, so it's like the short square plus the medium square equal to the longest square. Pythagoras theorem. All right, if you haven't learned perfectly, it's okay. Don't worry. All right, this is just an idea. All right, next time you will learn this Pythagoras theorem. Short square, 6 square, plus the medium, 8 square equal to the longest square, which is the L. And L is called the hypotenuse. Hypotenuse means the longest side of a right angle. It must be a right angle triangle. So down here you calculate 6 is 36, 8 is 64, is equal to L square. So 100 is equal to L square. How to find L? L is equal to, you have to square root 100. Oh, L is equal to plus and minus 10. Again, every time you square root, you must give the plus and minus portion. And therefore, you can conclude L is equal to 10 cm and give a bracket, negative 10 is being rejected. Can you see that my working, right, is very consistent to just now also? All right, so you have to be consistent in your steps in mathematics. So when your L is 10 cm, you can put it in already. All right, let's activate. Pi is 22/7. Radius of the cone is a 6. L is given as 10 plus 2 times pi is 22/7. Radius of the hemisphere is the same as the radius of the cone, is 6 square, is a 6. So you key everything into calculator again. 22/7 times 6 times 10 plus 2 times 22/7 times 36. Bam, answer will be 414 6/7 cm square. All right, so this is the exact answer. Give the exact answer. That will be the best. Okay, and that will be the total surface area of figure P. Oh, I see until my back. Oh, pain. All right, 3-hour lesson. Very tired. Okay, hopefully you can understand what the formulas are there for. All right, it's there to help you. So if you can understand the formula, if you cannot, never mind. Do remember it. All right. Okay, so these are the question, the 5 questions. Hopefully this helps you, right, for the Sec 1 and Sec 2. All right, and that's it for today's lesson. Okay, if you need more practice once again, right, for if you're in Sec 1, you can go to lesson 33 and 34 inside our 88 Tuition, the website. All right, if you're under some trial lesson or if you have purchased the whatever, the package already, right, you'll be able to find more such lessons in lesson 33 and 34 for Sec 1. And for Sec 2, you can go on to lesson 29 and 30. All right, down there got more examples and there's more questions for you to practice on. All right, so hopefully you can go and visit and make your math perfect. Any math question, you can actually WhatsApp me at 8933-0213. All right, if I think that is a very, very good to discuss question, I will bring it up in our next lesson. Cool. And that's it. That's it for this lesson. Hopefully you learn something and gain some knowledge down here. All right, so don't give up on math. You can do it and be what? Be positive. All right, and remember to stay at home. All right, keep yourself safe and take care of yourself. All right, then that's it for this lesson, and I'll see you in our next lesson next week the same time. Okay, all right, see you on the next lesson. Bye bye.